All right, let's talk about one of the biggest game changers in the blockchain world, smart contracts. Now, these are way more than just lines of code. We're talking about a completely new way to make and enforce agreements, all without needing a middleman. It's a pretty revolutionary idea.
I mean, just think about that for a second. What if a contract could just run itself? No lawyers needed, no one checking things by hand, no third party you have to trust, just an agreement that automatically does what it's supposed to do the very instant the conditions are met. That's the huge problem smart contracts were built to solve.
So, what is a smart contract, really? The best way to think about it is like a super-powered vending machine. You know how it works, right? You put your money in, you make your selection, and boom, the machine automatically gives you your snack. There's no person involved. A smart contract is basically that, but for digital agreements. It's a program living on a blockchain that just follows simple, if this happens, then do that rules. It's all automatic.
And here's where the magic happens. First, all the rules of the agreement are hard-coded and locked onto the blockchain. And locked is the key word. They're immutable. They can't be changed. Second, the contract is constantly watching the network, waiting for the specific conditions to be met. And finally, as soon as those conditions are true, it triggers an action. That could be anything from transferring money to updating a record of ownership. The whole thing just runs on its own.
And listen, this isn't some far-off future tech. It's already here, and it's powering some incredible stuff. You've got the entire world of decentralized finance, DeFi, that runs on smart contracts. NFT marketplaces, they're the engine that makes them work. But it goes even further. They're being used to track products in supply chains, to verify our identities, and even to run the economies inside video games. Their footprint is just getting bigger and bigger.
Okay, so how do you actually build one of these things?
Well, it's a really careful and precise process. This isn't like building a website where you can just push an update if you find a bug. Once a smart contract is out there on the blockchain, it is out there. The pressure to get it 100% right from the very beginning is immense.
It all kicks off with defining the logic. You have to translate the rules of a real-world agreement into code that has zero ambiguity. Then a developer picks a language. Solidity is a really common one for the Ethereum blockchain. And then comes maybe the most critical step of all, testing. And I mean extensive testing. You have to simulate every possible thing that could happen, every edge case, to make absolutely sure the contract is going to behave exactly like you designed it to. And that need for perfection leads us right into the single most important part of this whole conversation, security. Because with smart contracts, if something goes wrong, there's often no do-over.
This quote really hits the nail on the head. We're not talking about a simple bug that you can just patch later. A tiny flaw, a small mistake in the code of a smart contract can be exploited by an attacker, leading to massive, and I mean irreversible losses. The code is law, as they say, but if that law is flawed, it can be a total disaster. And here are some of the developers' worst nightmares. You've got things like reentrancy tax, which is a clever way for a hacker to trick a contract into giving them money over and over again. Or even simple math errors like integer overflows, a classic programming bug that becomes catastrophic when you're dealing with millions of dollars in assets. Every single one of these is a potential backdoor. So, how do you defend against this? How do you build a fortress? You do it by being incredibly disciplined. It means you don't reinvent the wheel. You use code libraries that have already been battle-tested and audited by experts. It means you give every part of your system the absolute minimum power it needs to do its job. And you know what? A lot of the time, it means building in an emergency pause button just in case the worst happens. But the job isn't done just because the contract is deployed securely. See, these contracts don't live in a bubble. They're part of a much bigger system, and they have to be managed and, believe it or not, sometimes even updated. This is a really important distinction to get. The smart contract code itself lives on-chain. That means it's permanently recorded on the blockchain, where anyone can see it and check it. But the websites you visit or the apps you use to interact with that contract, that's all off-chain. For anything to work, you need both the on-chain and off-chain parts to communicate perfectly. And this brings us to a really fascinating puzzle. The whole point of a smart contract is that it's immutable, right? It's not supposed to be changed. So what happens if you find a bug after it's been deployed? Or what if you just want to add a new feature? How in the world do you update something that's designed to be unupdatable? Well, the answer is a really clever piece of engineering called a proxy pattern. Here's the basic idea. Your users interact with one contract, the proxy, and its address never ever changes. But that proxy contract's only job is to forward all the requests to a different contract that contains all the logic. And that logic contract, that can be swapped out for a new one. It's like having a permanent PO box, but you can change where the mail gets forwarded to. It lets you upgrade the rules while keeping all the user data and the contract's public identity the same. Of course, this raises a new question. Who gets to approve the upgrade? And that shifts the challenge from code to governance. Okay, so let's zoom out and pull all this together. We've gone through the how, the what, and the what to watch out for. So why does all this matter so much?
Well, the potential here is just enormous. Because every single action is on a public, tamper-proof ledger, you get radical transparency. By cutting out the middleman and automating everything, you get huge boosts in efficiency and reliability. And when you add all that up, you get systems that are faster, cheaper, and frankly, a whole lot more trustworthy. But, and this is a big but, getting to that promised land is not a walk in the park. As we've seen, it all boils down to discipline. Real success with this technology is built on a foundation of airtight logic, an obsession with security, and smart design that thinks about the whole system, both on-chain and off-chain. And that kind of leaves us with one final big question. As this tech gets better and more common, more and more of our digital lives are going to be run by these autonomous bits of code. Think about everything from hiring a freelancer to trading complex financial assets. So the question really isn't if we'll start trusting code with these agreements, but what's the next big thing you'll be willing to trust to it?